First, very common, let me write it, very common in limit, or we can say that the application of the limit, one of the very common application is differentiation. And if we see, for the better understanding, fx is equal to sine 2x, sine 2x. So we know that f of 0 is equal to f dash 0 is equal to, according to the differentiation, so definition, what we can say, according to the definition, what we can say here, like limit h tends to 0, limit h tends to 0, here is f of a is equal to 0 plus h and minus f of 0 divided by h. So if we solve this, is it also equal to differentiation of x, differentiation as at x is equal to 0. Yes, yes, we know this. So let me solve that. The fx is equal to sine 2x. If we put here, like in terms of the limits, limit h tends to 0, at the fx we are going to put what, the sine 2x. So this is the sine 2x, but here we are solving in terms of h, then sine 2h minus sine, here is 0, yes, and upon h. So if we solve, this is 0, yes, this is 0. So if we solve this, then we will get the 0 by 0 form, 0 by 0 form. Here is 0, we are taking the value of sine 2x at the value of 0 is 0. How? Let's see. At, let me change the color. Yes, at x is equal to 0, sine 2x is what? If we put it's not h, x, it is h. H is equal to 0. So this is going to be function in fx is equal to sine 2x, and if we put x is equal to h is equal to 0, then this is going to be sine 2h, and this is going to be 0, nearly or approximately to 0. The whole value is going to be 0 for this. So this is also, we can say that this is going to be sine 0, then this value goes to 0. Okay, so let me talk about the indeterminate forms. We understand now, we got that the main idea indeterminate form, and if it is a 0 by 0 form, this is a quotient indeterminate form. So first we need to see the types of indeterminate forms, and then we need to understand what type of the indeterminate form is and how is it looks, how we can recognize these forms. So let's see one by one, and we will further we will solve a bunch of questions, so everything is easy for you. Okay, so first we are going to see the indeterminate form. So first we are going to see the quotient indeterminate form. So in quotient indeterminate form, what we actually do, let's say for the limit x tends to a, there is a function fx and another function which is a gx. If this function is going to be in the form of 0 by 0, like we have seen in the definition of the indeterminate forms, like 0 by 0 or infinity by infinity. If this form is going, this function is going to be in the form of 0 by 0 or infinity by infinity, so we have a rule which is L'Hopital's rule, which is L'Hopital's rule. With the help of this L'Hopital's rule, we can solve this 0 by 0 or infinity by infinity forms. So what type of function which is we can get in the form of 0 by 0? Let's see for the example. Let's see limit x tends to 0. I'm just taking a simple examples to understand what is the 0 by 0 form is. But we have seen another form in the first indeterminate definition. But here we are going to see the simple problem. Like here it is also in the form of 0 by 0 form. And another form is going to be is infinity by infinity. Yes, infinity by infinity. So let me take one example. Let me take any trigonometric function. Let me remember. Okay, we are going to make a trigonometric problem. Limit x tends to 0 and x tends to 0, x by x, and on the numerator we can add the sine x. It's in the product sine x, sine 1 upon x. Randomly I have chosen a trigonometric function, and we are going to solve the limits for that function. Initially what we see, this is a x, and in the numerator we have x, and in denominator we have x. Yes, so it is going to be what? 0 by 0 form. Yes, and the sine x, sine 1 upon x is going to be, let's check the sine 1 upon x. So how, for the sine 1 upon x, sine, if the x, this x is going to be 0, so the value is going to be infinite. 1 upon infinite form, 1 upon infinite form, this is also going to be 0. Yes, and 0 by 0. Yeah, so if it is in the bottom, if it is 0, then this function is going to be undefined, does does not exist. We can say that this function is what? The does not, limit does not exist for this function. Why? Because sine 1 upon x, 1 upon x is going to be the 0, near to 0, and if the value is going to 0, the sine value is going to be infinity. But it is not possible. Sine value is going to be 0 or 1. It is not possible to be infinity. So this limit is not going to hold, does not exist. And let me solve another. Okay, let's see. We will solve a bunch of questions for the quotient indeterminate form. So I'm going to go for the second form, that is the, let's see, for the product indeterminate form. Yes, product indeterminate form. How we can recognize this is product indeterminate form? Let's see if it is types of a 0 to infinite or 0 to infinite. We can say that this is what the quotient indeterminate form. So let me take the example. Limit x tends to 0. Yes, x ln x. Yes, this is the example, and we are going to see what the, is it in the form of a product indeterminate form or not. So yeah, this is going to be approximately 0, and ln, what we can say that this is the natural logarithmic natural logarithmic of x. So this value, if this x is going to be 0, so value is going to be minus infinity. Yes, so this is also, this is the product indeterminate form. This is what the product indeterminate form, and we are going to see the third indeterminate form, that is subtraction indeterminate form. So subtraction indeterminate form is like infinity minus infinity. So for example, let me take one example so that will be easy to understand. So example, for example, let me take a simple example, a little medium example I can say. Okay, so x tends to infinity. Yes, and there is a square root, and in square root there is a quadratic function. It's a quadratic function, that is x square plus 3x plus 5 and minus x. So for this function, we are going to see this limit is in the form of subtraction indeterminate form or not. So let me solve. For first this square root. So if x tends to infinity, then this is the dominant term in this function, like x square, because we have infinity, it is tending to infinity. So this is going to be dominant in these terms. So x square is going to be infinity. Infinity is square is infinity. Then this whole thing is going to be infinity, and this is also going to be infinity. So whole thing is going to be infinite. And here, if it is tending to infinity, then we can say that it is approximately infinity. Yes. So yeah, there is a sign, so we can put that sign. So what we can say that this is the form of subtraction indeterminate form. This is the subtraction indeterminate forms. This is look like this. We can easily understand what how is it looks. Okay, so further we are going to see the exponential indeterminate form. So how we can recognize this is exponential indeterminate form or this is not an exponential indeterminate form? So let me see first. This is the 0 power 0, or if it is look like the infinity power 0, or the 1 power infinity. So in mathematics, if this is if we got that 0 power 0 or infinity power 0 or 1 power infinity, we can say that this is the exponential indeterminate form. In mathematics, 0 power 0 is 0. Yes, and if we want to understand with the help of the graph, so let me draw that graph, and this is what the 0, this is x. For any power of 0, it is 0. 0 power 0, 0 power 1000, 0 power 100,000, then all is going to be 0. So now we have completed the indeterminate forms, and there is a in this video we have seen 4 indeterminate forms. First is quotient indeterminate form, second is product indeterminate form, and third is subtraction indeterminate form, and fourth one is exponential indeterminate form. Okay, we have completed.